Try to imagine, for instance, a dull sound, like a thump, something that produces a sinister noise, something that tells us that yes, Houston, we have a problem, and it's serious. And then, after that sound, you may hear someone screaming and the production line that suddenly stops. Okay, this is what might happen when ceramic tiles explode inside the kiln during the firing cycle. But what are the origins of the problem and what kind of action must be taken to avoid or at least reduce it? I am Davide Trentini and this is Apparently Invisible: Chemistry in Ceramic. Let's start from the beginning. During the firing cycle, tiles usually heat up gradually, and we could say also constantly. Of course, during the heating process also starts the water evaporation process, water that is present both on the surface and inside the ceramic body. The heating process can change according to dimensions and thickness of the ceramic to be produced, but we generally can say that the temperature increase that occurs inside the kiln should be constant as well as calibrate to reach a final good result. The evaporation process involves and produces a water migration from inside to outside the ceramic material, and this migration does not lead to any problems when it develops properly, but it can be a serious issue when it takes place incorrectly. By the way, when does the evaporation process start? It usually starts in the first part of the kiln and specifically in the preheating phase. And in this regard, it is important to underline that in this phase, no chemical or physical changes have taken place yet, within the ceramic body, of course. This means that clays, sands, and feldspar have not merged yet. In other words, the sintering process, that is the microcasting process that melts together the spheres of the ceramic mixture, is yet to come. Let's now add a new element. We are talking about water, but what kind of water are we talking about? And sorry for the play on words. To put it plainly, we can identify two different kinds of water. The residual humidity, that is a water that is not chemically bound to the inorganic parts of the tiles, and the hydration water, a water that is chemically bound to the ceramic body structure. The latter, since it is structurally bound to some of the inorganic component of the support, needs more time and higher temperatures to evaporate. To better explain the reason why time and temperature are different between the two, we can take an example from the world of cooking, where chemistry surprisingly plays a very important role. If, for example, we simultaneously put on fire a glass of water and a glass of gelatine, we could realize that the water inside the gelatine needs more time to evaporate. Why? That is because that water is bound to the isinglass that is in the gelatinous mix, just like the hydration water. And going back to ceramic, as we have already seen, the evaporation process takes place in the preheating phase due to the progressive and constant temperatures increase. We could say till 300-400 degrees. This gradual increase in heat is called temperature gradient, and it plays an essential role on the proper water evaporation process. What does that mean? It means that when the gradient is constant and slow, the water inside the support has enough time to migrate outside the tiles, and so to evaporate properly and naturally. On the contrary, when the temperature's increase is not constant and or too rapid, the ceramic body can finally explode. What exactly happens? When the water reaches too rapidly a very high temperature, much higher than 100 degrees, for example, it happens what we could commonly call the pressure cooker effect. The water, heating too rapidly, produces a violent pressure that it turns in a strong expansion inside the ceramic body. The pressure, together with the expansion, can affect the mechanical features of the material, producing a deformation and then the explosion of the ceramic support. Very good. Let's now go further by adding a new important and interesting detail. As we have just seen, the breaking of tiles may be caused, for sure, by the improper water evaporation process, but it can also be promoted by the density of the ceramic body. In what way? Let's try to explain it in simple words. As we know, raw materials undergo to a very high pressure during the pressing phase to get a resistant ceramic body and therefore to avoid possible damage on the conveyor belts of the production line. However, a high-density material that we could more simply define as a compact material forces the evaporation water to produce a greater effort during its migration from the ceramic support to the air. The higher is the density, the more likely the problem arises. And so, what action can be taken to avoid or to control the problem? First of all, the solution is almost always to be found in the production phases that take place before the firing process, especially along the glazing line when waters are added in large amount both on and inside the ceramic body. Let's try to make a list of the main possible actions. The first action is for sure the most complex and delicate, but at the same time the most effective. Here it is. It is important to study very carefully within the lab the rheological features of the solution according to the specific production conditions, raw materials, news, production machines, kind of application, technical and aesthetical feature of the product tiles to be produced. This means that it is important to provide the watery solution that are engobes, glazes and grid suspensions with the proper values of density, viscosity, flow limit, etc., so that they can be correctly combined to the specific parameters of the production line. For example, it is possible to change the rheologist features by increasing the density of glazes and engobes that, as we know, usually contain a large amount of water. This means, in other words, to reduce the water's rate. Another option is to decrease, during the pressing phase, the weight applied on the inorganic raw materials that form the ceramic body. Just to give you an example, we could decrease it from 450 to 420 kilos per square centimeter. This weight reduction, even if it seems very modest, it significantly affects the density value of the ceramic body. And, of course, this reduction helps the water migration process, helping us to reduce the problem. Another way to get around the problem is to make a clear choice in terms of application technology. The most effective, and of course the most obvious, is to switch from a wet to a dry application system. The latter, that it develops by matching a digital glue application with a dry grid application, involves of course a very lower amount of water that, as we have seen, is one of the most important responsible for the problem. Finally, the last option that we put on the table is quite crazy because it is not very feasible, but it clearly explains the role of the kiln. What I mean, we could increase the duration of the firing phase so to facilitate the proper evaporation process. This is theoretically a good option, but of course it will not be taken into consideration because it seriously affects the productivity of the industrial process. And so our first stop ends here. I apologize for my English and I thank you very much for traveling with us. I hope I gave you some food for thought, and if yes, you can of course contact us by email that you can find on our website, which is ceramco.et, ceramco.et. I am also glad to inform you that all the podcasts are available not only on the main platform, from Spotify to Apple Podcast, but also on our app that you can download for free on Apple Store or Google Play. You can find it by digiting Zeta and S Ceramco or apparently invisible. As we usually say in our labs, standard is impossible. In ceramic field, only tailor-made solutions are possible. See you in 2 weeks.